everyone, welcome to the Pythagorean Theorem guided notes. We will begin on focusing on right triangles. A right triangle is a triangle with one 90-degree angle. We are going to learn how you can calculate the lengths of the sides of a right triangle. Given the length of the sides of a right triangle, you can always calculate the length of the third side. Let's figure out how to do so by looking at this square below. We have this bigger square and we have this smaller square here in the middle, and then we have these similar triangles here on the outside with a shorter length of A and a longer length of B. We are going to determine the area of the large outer square. We will do so in two different ways. First, to find the area of a square, you can square the length of a side. The length of one side of this bigger square is A plus B. And I get that from right here. A plus B is the length of that square. Now we're going to square the length to get the area of the square. So we have A plus B squared, which is the same as A plus B times A plus B. And then we're going to distribute that and we get A squared plus AB plus AB plus b squared. If we combine those two middle terms, we get that to equal a squared plus 2ab plus b squared. Now we are going to find the area of the large outer square by finding the sum of the area of the parts that make up the larger square. The parts that make up the largest square are, we have 4 triangles and one smaller square there in the middle. The height and base of the triangles, look right here, we have the height and the base are going to be A and B. The side length of the square right here is length C. So now on this next question, we're going to sum the area of the parts. So since we have 4 triangles with base and height of A and B, the area of the triangles are going to be A times B divided by 2, and they're going to do it 4 times because there's 4 triangles. So this is right here the area of the 4 triangles, and this is the area of the square in the middle. So if I add up all these areas, I'm going to get the area of the bigger square. So now we're going to simplify here. So that gives me 4AB divided by 2 plus C squared, and that equals 2AB plus C squared. Now we have found the area of the large outer square in 2 different ways. Now we will set them equal and simplify. So we figured out that the area of the square equaled A squared plus 2AB plus B squared. And remember on the previous page, we did that right here by squaring the length of the side, A plus B. Then we summed the area of the parts right here, and we got 2AB plus C squared. So those actually equal each other. Now, if we simplify them, I can subtract 2AB from each side. Those cancel out, and I get A squared plus B squared equals C squared. You have just proven this is called the Pythagorean Theorem. The Pythagorean Theorem can help us determine the side lengths of a right triangle. A right triangle consists of 2 sides that form the right angle, and one side that is opposite the right angle. The 2 sides that form the right angle are called the legs. They are labeled as A and B in the Pythagorean Theorem. The side opposite the right angle is called the hypotenuse. This is labeled as C in the Pythagorean Theorem. So the Pythagorean Theorem states that A squared plus B squared equals C squared. And I'm just going to draw a little picture right here. If I have a right triangle, here's my right triangle, here's my right angle. I'm going to have A and B be the lengths of the side that form that right angle, and the hypotenuse is the opposite side length, and that's labeled C. Look at the following right triangle. The length of the legs are 3 and 4 inches. Substitute those values into the Pythagorean theorem. So one of these is A and one of them is B. It doesn't matter what is A and what is B as long as they're the sides that form the right angle. So I have A squared plus B squared equals C squared. So I'm going to substitute that in. I get 3 squared plus 4 squared equals C squared. Now I'm going to simplify the left side of the equation. 3 squared is 9, 4 squared is 16, and that gives me 25. So 25 equals C squared. To solve for C, we will need to take so remember when I have a squared, to get rid of the squared, I'm going to take the square root. So taking the square root of each side of the equation, square this side and square this side. Right here, this squared and square root will cancel out. So the square root of 25 equals 5. Technically, it also equals -5, but since we're talking about lengths, we're just going to talk about the positive values. So the hypotenuse C equals 5. The length of the legs right here are 5 and 12. Substitute those values into the Pythagorean theorem. So A squared plus B squared equals C squared. So I have 5 squared plus 12 squared equals C squared. Solve for the hypotenuse of the triangle. So continuing to simplify here, I have 5 squared plus 12 squared equals C squared. 5 squared is 25. 12 squared is 144. That equals C squared. 25 plus 144 is 169 equals C squared. I'm going to take the square root of each side. So the square root of 169 equals 13. So the hypotenuse C equals 13. The lengths of the legs of an isosceles right triangle. So remember, isosceles means that two side lengths are the same, and they are 3 centimeters. Calculate the hypotenuse. Note, no drawing is given. However, drawing your own picture is a good strategy to help you visualize the problem. All right, so let's go ahead and draw a picture of a triangle. I know it's a right triangle, and I know the leg lengths are the same, so I'm going to do my best to do that. And I'm going to label them. I know the leg lengths here are 3, and I'm trying to figure out the length of the hypotenuse, side C. Substitute the given values into the Pythagorean theorem. So that's A squared plus B squared equals C squared. So 3 squared plus 3 squared equals C squared. Solve for the hypotenuse of the triangle. So 3 squared is 9, plus 3 squared is 9. That equals C squared. 9 plus 9 equals 18, which equals C squared. If I take the square root of each side, I get C equals the square root of 18. Now, it depends what the problem's asking. Sometimes it just asks it to leave it in simplest form. Sometimes it asks you to maybe actually use a calculator and figure that out. So the square root of 18, you're going to simplify, that goes to 9 and 2. So 9 is a perfect square, so that's 3 root 2, which is about 4.2. The hypotenuse equals 3 root 2, which is about 4.2. Error analysis. Determine the error in the following calculations. A right triangle has leg lengths of 6 centimeters and 8 centimeters. Travis needs to determine the length of the hypotenuse. His calculations are below. Identify and explain Travis's mistake. So he has A squared plus B squared equals C squared. That's the Pythagorean theorem. It's a great place to start. He has substituted his leg length, 6 squared and 8 squared, into there. So that looks good. He has simplified 6 squared and got 36, simplified 8 squared and got 64. And let's see, 36 plus 64 equals 100. So that's good. Oh, but he says that equals C. That doesn't equal C. That equals C squared. He forgot to take the square root of that equation to figure out what C equals. So let's write that here, of 100. Practice. Determine the length of the hypotenuse. Here I am given a right triangle, and I need to determine the length of this here, the third side, the hypotenuse, which is opposite the right angle. So I'm going to use the Pythagorean theorem of a squared plus b squared equals c squared. Let's substitute the lengths of the legs into the theorem. So we have 2 squared plus 1.5 squared equals c squared. 4 plus 1.5 squared is 2.25 equals c squared. 4 plus 2.25 is 6.25 equals c squared. Remember, I'm not done yet. I need to take the square root of each side, and that gives me c equals 2.5 meters. Next one, my leg lengths are 4 and 9. So let's write down the Pythagorean theorem, a squared plus b squared equals c squared. Substitute it in, I get 4 squared plus 9 squared equals c squared. So 16 plus 81 equals c squared, or 97 equals c squared. Taking the square root of each side, I get c equals the square root of 97, which is about 9.85. A screen has side lengths of 10 feet and 24 feet. What is the length from one corner to the opposite corner? So if you need to draw a picture, my screen will be a rectangle, and I want to figure out the length from one side to the other side. It tells me that the lengths are 10 feet and 24 feet, and I need to figure out this distance right there. So we're going to use the Pythagorean theorem. We'll have a squared plus b squared equals c squared. Substituting in my side lengths, I have 10 squared plus 24 squared equals c squared. So 100 plus 24 squared is 576 equals c squared. So 676 equals c squared. Last step, take the square root, and the square root of 676 is 26, so 26 feet. A right triangle has a length of 1 meter and the square root of 15 meters. What is the length of the hypotenuse? So it's telling me that the leg lengths are 1 meter and the square root of 15 meters. Starting with the Pythagorean theorem, a squared plus b squared equals c squared. So I'm going to put 1 squared plus the square root of 15 squared equals c squared. 1 squared is 1. The square root of 15 squared, that will cancel each other out. So that's going to give me 15 equals c squared. 16 equals c squared. Last step, take the square root, and I get c equals 4. Now we're going to talk about the converse of the Pythagorean theorem. The converse means if I'm given the hypotenuse of a right triangle and the length of one of the legs of a right triangle, then I can figure out the length of the other leg. Given the measure of a leg and a hypotenuse of a right triangle, let us determine how to find the measure of the other leg. Using the drawing, the measure of the hypotenuse is, so here's my hypotenuse right here. It is opposite the right angle, and the length of that hypotenuse is 12.5. And the measure of the given leg, right here, it gives me this leg, and that is 7.5. Substitute the values into the Pythagorean theorem. So up here I have my Pythagorean theorem, a squared plus b squared equals c squared. And one of my legs, a squared, is going to be 7.5 squared. I don't know the length of my other leg, b, so we'll just keep that as b, plus b squared equals 12.5 squared, because remember 12.5 is the hypotenuse. Now it tells me to simplify it. So 7.5 squared is 56.25 plus b squared equals 12.5 squared, which is 156.25. Now it tells me to isolate the variable. So let's get the b's by themselves by minusing 56.25 from each side. That will cancel over there, and I get b squared equals 100. Now your equation reads as a variable squared equals 100. How can you solve for the variable rather than take the variable squared? So right here, I know b squared equals 100. To solve for b, I'm going to take the square root of each side. The measure of the other leg is 10, because the square root of 100 is 10. The length of the hypotenuse is 3.25 inches. The length of the given leg right here is 1.25 inches. Substitute the values into the Pythagorean theorem. So again, we have a squared plus b squared equals c squared. C squared is my hypotenuse. A and b are my legs. So I have 1.25 squared plus b squared equals 3.25 squared. Now I need to go through and solve for the other leg. So 1.25 squared gives me 1.5625 plus b squared equals 10.5625. I'm going to subtract 1.5625 from each side. Then I get b squared equals 9. And last step is to take the square root of each side. So that means b equals 3 inches. The slant height of the cone is 41 centimeters. The altitude is the perpendicular distance right here. And it's telling me that that is 40 centimeters. Then it wants me to determine the diameter. So I can look at this triangle right here, and I'm going to figure out this distance here at the bottom, and that will give me the radius, and then I'm going to figure out the diameter by doubling the radius. That's my thinking. So substitute the values into the Pythagorean theorem. So a squared plus b squared equals c squared. My leg is 40, so 40 squared plus b squared equals 41 squared. 40 squared is 1600 plus b squared. 41 squared is 1681. I'm going to minus 1600 from each side to isolate the variable, and I get b squared equals 81. Last step, don't forget, take the square root, and I get b equals 9. So I know that my radius is 9, but it's asking me for the diameter, so that's going to be 18 because it's going to be double the radius. And it says, caution, make sure you solve for the diameter and not the radius. So yeah, double check your work there. Determine the error in the following calculations. A right triangle has a hypotenuse of 17 feet. One leg measures 15 feet. Determine the length of the third leg. We have the Pythagorean theorem, a squared b squared equals c squared. And then we had 15 squared, which is one of the legs, plus 17 squared. Now 17 squared is the hypotenuse. So this is not going to work because the hypotenuse needs to be substituted in for c, not for one of the legs. Practice. Determine the length of the unknown side. So here I am given the hypotenuse and the length of one of the legs. So I'm going to start with my Pythagorean theorem, a squared plus b squared equals c squared, and substitute in. So 8 squared is one of my legs, b squared is one I don't know, c squared is the other one, so 17 squared. Simplifying, I have 64 plus b squared equals 17 squared, which is 289. And then I'm going to minus 64 from each side to get the b squared by itself. And I have b squared equals 225. And then I'm going to take the square root of each side, and I get b equals 15 meters. Okay, next question. Again, I have the hypotenuse and I have a leg. So starting with the Pythagorean theorem, a squared plus b squared equals c squared. A squared will do square root of 3 squared plus b squared, I don't know. C squared is 2 squared. So the square root of 3 squared, those will cancel each other out. And that gives me 3 plus b squared equals 4. I'm going to minus 3 from each side. And I get b squared equals 1. Taking the square root of each side, and I get b equals 1 inch. A rectangular window has a side length of 35 inches, and the distance from one corner to the opposite corner is 37 inches. What is the height of the screen? We have a rectangle, and it tells us the length of one side is 35 inches, and then the distance from one corner to the other corner is 37 inches, and I need to figure out the height. So starting with the Pythagorean theorem, a squared plus b squared equals c squared. I know the length of one leg is 35. I don't know the second leg, and then the hypotenuse is 37. 35 squared is 1,225 plus b squared equals 1,369. I subtract 1,225 from each side, and I get b squared equals 144. Last step is take the square root, and I get b equals 12. So the height of the screen equals 12 inches. A right triangle has a hypotenuse that measures 5 inches. One leg measures 2 inches. What is the length of the other leg? Okay, we're going to start with the Pythagorean theorem. A squared plus b squared equals c squared. One leg measures 2 inches. We don't know the second leg. And then the hypotenuse is 5 inches. Simplifying, I have 4 plus b squared equals 25. I'm going to subtract 4 from each side, and that gives me b squared equals 21. I'm going to take the square root of each side, and I get b, or the height of the other leg, is the square root of 21, which is about 4.6 inches. Now we're going to use the Pythagorean theorem to find distances on graphs. It says graph the points negative 2, 3, and 4, 6. So we have negative 2, 3, which is over 2, down 3, so right here. And then we have the point 4, 6, which is over 4, up 6. We are going to use the Pythagorean theorem to determine the length of that line. So we're looking at that line right there between the 2 points. We want to determine the distance of that line. To determine the length of that line, create a right triangle on the graph with the line that you drew as the hypotenuse. So we're going to create a right triangle, and now I have a right triangle. How can you determine the lengths of the legs? So how can I figure out these lengths? I can figure this out just by counting the units on the graph. The lengths of the legs are, so right here, if I count this, I have 1, 2, 3, 4, 5, 6. So that one is 6. And then if I count this one on to the side, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So the lengths are 6 and 9. Use the Pythagorean theorem to determine the length of the hypotenuse. Okay, so let's start with a squared plus b squared equals c squared. I know the lengths of my legs are 6 squared plus 9 squared, and that is c squared. So 6 squared is 36, 9 squared is 81. Add those together, and I get 117 equals c squared. So the length of the hypotenuse, I'm going to take the square root, is going to be the square root of 117, which is about 10.8 units. It says graph the points negative 1, 7, which is right here, and 7, 2 on the graph. We want to determine the distance between the 2 points, which would be this distance right here. I'm going to create a triangle to figure out the length of the legs there. I'm going to count the lengths of the legs. So 1, 2, 3, 4, 5. That length is 5. And then the horizontal length down here at the bottom is 1, 2, 3, 4, 5, 6, 7, 8. And I want to figure out the length of that distance right there. So we have our Pythagorean theorem, a squared plus b squared equals c squared. Substituting in values, I have 5 squared plus b squared equals 8 squared, which means 25 plus b squared equals 64, minus 25 from each side, and I get b squared equals 89. Taking the square root of each side, I get b equals the square root of 89, which is about 9.4 units. Explain how you calculated the distance. I determined the length of the legs by counting the units on the graph. I substituted the values into the Pythagorean theorem and solved with a hypotenuse. Let's do some practice problems. We are going to determine the distance between each pair of points. So let's start by graphing the points. We have negative 7, negative 2, and then 6, 0. So I'm determining this distance right here between the 2 points. Let's create a right triangle. Again, it doesn't really matter if I do it up or down from it, but let's just do it like this. Now I need to label the distances there. So over here on the left side, I have 1, 2. That is a distance of 2. And then on the top, My distance is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Using the Pythagorean theorem of a squared plus b squared equals c squared, my two legs are 2 and 13. Plugging those into the formula, 2 squared is 4, 13 squared is 169, and that gives me 4 plus 169 is 173, which equals c squared. So taking the square root of that on both sides, I get that the length c equals the square root of 173, which is about 13.2 units. Next question, I have the point 5, 3 right here, and the point 4, negative 4 right here. And I'm trying to find this distance that is right here between them. I'm going to create a right triangle and label the distances on the triangle. So the bottom distance is 1, and then the distance on the side is 1, 2, 3, 4, 5, 6, 7. Now using the Pythagorean theorem of a squared plus b squared equals c squared, I have 1 squared plus 7 squared equals c squared. 1 squared is 1, 7 squared is 49, so that equals c squared. 1 plus 49 is 50, which equals c squared. Using the square root of that, square root of 50, square root of 50, I can actually simplify square root of 50 because 25, which is a perfect square, goes into that. So that would be 5 root 2, which is about 7.1 units. Last question, I'm plotting the points 1, 2, and 8, negative 6. I'm looking at this distance right here between them. I'm going to create my right triangle and determine the side lengths of the triangle. So 1, 2, 3, 4, 5, 6, 7, 8. That length right there is 8. And then on the bottom, I have 1, 2, 3, 4, 5, 6, 7. That length is 7. Using the Pythagorean theorem, a squared plus b squared equals c squared. So I have 7 squared plus 8 squared equals c squared. 7 squared is 49. 8 squared is 64. That equals c squared. Adding those together gives me 113 equals c squared. Taking the square root of each side, and I get that c equals the square root of 113, which is about 10.6 units. Okay, everybody, that's it for today. Thank you.